In this lesson, you will learn to identify lines that are parallel and to write equations of parallel lines. We are going to begin by graphing sets of equations on a coordinate plane. So given the equations y equals negative 3x plus 5 and y equals negative 3x minus 2, we are hopefully going to be able to identify some similarities and differences that make these lines parallel. So both of these equations are in slope-intercept form, so we can recognize our y-intercept is positive 5, so we can plot a point on the y-axis at 5, and using our slope of negative 3 to go down 3 and to the right 1 and make another point, and continue, so go down 3 to the right 1 and make another point, and we'll make one more point and then connect those points with our line. And so given the equation y equals negative 3x minus 2, so our y-intercept on our y-axis is the point negative 2. And using the slope of negative 3, so going down 3 into the right 1 and make a point. And I can also reverse that and go to the left 1 and up 3 and make a point. And continue that, make another point, and a line. So there are the lines of the graphs of both of those equations. And so let's look at another pair of equations. So y equals 1/4 x minus 3 and the equation y equals 1/4 x minus 7. So the first equation, we have a y-intercept at the point 0, negative 3 with a slope of 1/4. So that means we rise up 1 and to the right 4 and make a point and continue up 1 over 4, make another point, and I'll go ahead and draw my line. And with the equation y equals 1/4 x minus 7, so a y-intercept at the point 0, negative 7 with a slope of 1/4, so up 1 and over 4 and make a point, up 1 over 4 and make another point, and we'll draw our line. And so we have these pairs of equations on the coordinate plane. And so I want you to think about, what do you notice about these pairs of lines? And hopefully there is something that you can recognize between both of the pairs that we have here. And these are what we call parallel lines. And parallel lines have the same distance between those lines all the way throughout the duration of the length of those lines. So one, they do not intersect, but you also have to be really careful. Just because they may not intersect on a particular graph that you can see doesn't mean that they would necessarily not intersect later on. So you have to be very careful that the lines are an equal distance apart as well. So then let's look at, what do we notice about the equations? So there has to be something within these pairs of equations that make these lines parallel. So let's look at some components of the first pair of equations that we have. So in the equation y equals negative 3x plus 5, we have a slope of negative 3. And in the second equation, we also have a slope of negative 3. Our y-intercept in our first equation is at the point 0, 5, and our y-intercept of our second equation is at the point 0, negative 2. So we can notice that our slopes of these two equations are the same, and our y-intercepts are different. So let's look at the second pair. So if we have y equals 1/4 x minus 3, our slope is 1/4. And looking at the next equation, our slope is also 1/4. And our y-intercept of the first equation is at the point 0, negative 3. And the y-intercept of the second equation is at the point 0, negative 7. So here we can also see that our slopes are the same and our y-intercepts are different. So we can generalize parallel lines as that have the same slope and different y-intercepts. And we're also talking about non-vertical parallel lines. So one of the first things we're going to look at is to determine if the following pairs of lines are parallel. So given the equation y equals 2x plus 3 and the equation y equals 2x minus 5, we are going to be looking for that same slope to see if these lines are parallel. So both of these equations are in slope-intercept form, so we can see our slope as our coefficient of x. So our slope of our first equation is 2, and the slope of our second equation is also 2. So that means that these lines are parallel lines. We can also notice that our y-intercepts are different. So let's look at another pair of equations. Y equals 2/3 x plus 3 and y equals negative 2/3 x minus 5. So both of these equations are also in slope-intercept form. So our slope is our coefficient of x, so the slope of the first equation is 2/3, and the slope of our second equation is negative 2/3. So just because the numerical part of the slope is the same, the sign is not, so these are not equivalent values for the slope, so these are not parallel lines. So looking at one more pair, we have y equals 3 divided by 1, x minus 7, and y equals 1/3 x minus 7. So recall here that the first slope, that coefficient, 3 over 1 or 3 divided by 1 is the same as 3. So our slope here is 3. And the slope of our second equation is 1/3. So these are not equivalent values, and so our lines are not parallel. So let's look at this set of lines. So we have the equation negative 5x plus y equals 7, and the equation y equals 5x plus 3. So we can see that the second equation is in slope-intercept form, but the first equation is not in slope-intercept form. So our first step then will be to convert this equation that's in standard form into slope-intercept form. So our goal is to isolate y. So we would move the negative 5x, so we're going to add 5x to both sides to do the inverse operation. So we have the equation y equals 5x plus 7. So in the equation y equals 5x plus 3, we can see that our slope is 5. And in the top equation that we converted into slope-intercept form, we can also see that our slope is 5. So our slopes are the same, our y-intercepts are different. So yes, these are parallel lines. So let's look at another pair. We have y equals 2x minus 6 and 6 equals 2x plus 3y. So our first equation is in slope-intercept form already, but we need to convert this second equation into slope-intercept form. So we have 6 equals 2x plus 3y. So we are going to subtract this 2x and move it to the left side of the equation. So we have 6 minus 2x equals 3y. If you prefer to write this as negative 2x plus 6 equals 3y, that would be mathematically correct as well. And we also then need to undo this multiplication of 3, so that inverse operation would be to divide both sides by 3. Also keep in mind that when you are dividing, you need to divide each term in your numerator by the denominator. So 6 divided by 3 would leave us with 2, and negative 2 divided by 3, we can just leave that as a simplified fraction of negative 2/3 x equals, and 3y divided by 3 would leave us with y. So we would have the equation 2 minus 2/3 x equals y. So one other thing that we can do to make this in slope-intercept form is to have y equals mx plus b. So we can also rewrite this as y equals, and take our x term, so our negative 2/3 x, and write that first, and then our y-intercept of positive 2, which is right here. So we can see from our first equation that our slope was 2. And in our second equation that we converted to slope-intercept form, we can see that our slope is negative 2/3. So our slopes are not the same, so these are not parallel lines. So in these examples, we are going to write an equation in slope-intercept form of a line parallel to each of these lines. So if we are given the equation y equals 1/2 x plus 5, we are trying to write an equation that is parallel to that line, but our line will have a y-intercept of negative 2. So since this equation is in slope-intercept form, we can see that our slope is 1/2, and parallel lines have the same slope, so we are going to use that slope in our new equation, and instead of having a y-intercept of +5, we are going to have a y-intercept of -2. So we can write this as y equals 1/2 x minus 2. So we take our slope, and we take our new y-intercept of -2 and plug that into the b of our slope-intercept form. If we are given the equation y equals -x minus 7, or the opposite of x minus 7, and now we would like a y-intercept of 6. So recall here that our slope is this negative, or that -1 value that is there, so we're going to keep that the same. And now we want a y-intercept of +6 instead of a y-intercept of -7. So we keep our slope the same, so we would have y equals -x plus our new y-intercept of 6. So in this example, write an equation in slope-intercept form of a line parallel to y equals 2x plus 5 and contains the point -1, 4. So here are some steps that we are going to follow to help us through this process. So the first step is to determine the slope, and we can determine the slope by looking at the m from the equation in slope-intercept form. So in this case, our equation that was given to us was y equals 2x plus 5, so we can see that our slope is 2. We are going to then substitute slope and the point into point-slope form, and then convert that point-slope form equation into slope-intercept form. So recall that our equation for point-slope form is y minus y sub 1 equals m, and in parentheses x minus x sub 1. So we are going to plug these values, or substitute these values, into our point-slope form equation. So we are going to take our slope from this equation and our point that is given to us, and substitute those values into the equation. So we would have y minus 4 equals 2, our slope of 2, and in parentheses x minus our x sub 1 value of -1. We can also write this as y minus 4 equals 2, and in parentheses x plus 1. So combining this minus negative, or the opposite of -1, would be a +1. In our process of converting to slope-intercept form, we need to distribute the 2 through to both terms in the parentheses. So we would have y minus 4 equals 2 times x is 2x, and 2 times 1 is 2. To get our equation in slope-intercept form, we need to have y by itself. So we would add 4 to both sides and have the equation y equals 2x plus 6. So this would be an equation of a line that is parallel to y equals 2x plus 5. So we can recognize that our slopes are the same, and our y-intercept of this new line that goes through -1, 4 has a y-intercept of 6, as opposed to this line that had a y-intercept of 5. Let's try another one. So write an equation in slope-intercept form of a line parallel to 3x plus y equals 5 and contains the point 2, -4. So we are going to follow the same steps. So determine the slope, which is the m from the equation in slope-intercept form. So given the equation above, we had 3x plus y equals 5. So we need to first convert this to slope-intercept form to determine the slope. So we would subtract 3x from both sides, and we would have y equals -3x plus 5. From this equation, we can see that our slope is -3. And so now we are going to substitute our slope and the point into point-slope form. So when we do that, we would have y minus our y sub 1 value, which is -4, equals the slope of our line that we're making this parallel to, which is -3, and in parentheses x minus our x sub 1 value of 2. We need to distribute the -3, and we can also change this minus negative, or the opposite of negative 4, to y plus 4. And when we distribute, we would have negative 3 times x is negative 3x, and negative 3 times negative 2 is a positive 6. To get y isolated, we would subtract 4 from both sides, and we would have the equation y equals negative 3x plus 2. So this line is parallel to this line, which is also equivalent to the line that we found here in slope-intercept form. So these two lines are parallel to one another. So what I want you to do now is to pause this video and work out these two practice problems that are involving writing equations in slope-intercept form of lines that are parallel to a given equation. So take a moment, pause this video, work out these two problems, and when you are finished, push play so you can check your answers. So given the equation 6x plus 2y equals negative 14, and we want a line that is parallel to that and contains the point negative 2, 5. So the first step you should have done was to get this equation in slope-intercept form so we can determine the slope of this line. So we would subtract 6x from both sides and have 2y equals negative 6x minus 14. We would divide both sides of our equation by 2. And so we would have y equals negative 3x minus 7. So our slope of this line is negative 3. So we are going to use that negative 3 when we plug our values into point slope form. So we substitute our slope and our point into the equation. So we would have y minus 5 equals negative 3, and in parentheses x minus negative 2. We could also write this as y minus 5 equals negative 3, and in parentheses x plus 2. So the opposite of negative 2 is positive 2. In our work here, we would distribute this negative 3, so we would have y minus 5 equals negative 3x minus 6. Add 5 to both sides, and our equation of a parallel line would be y equals negative 3x minus 1. In the second example, write an equation in slope-intercept form of a line parallel to y equals 1/3 x plus 7 and contains the point 9, 8. So this equation is already in slope-intercept form, so we can recognize that our slope is 1/3. So when we substitute our values into point slope form, the equation would be y minus 8 equals 1/3, and in parentheses x minus 9. We would distribute the 1/3 to both terms in the parentheses. So the equation would be y minus 8 equals 1/3 x minus 3. We would add 8 to both sides, and our equation of our parallel line would be y equals 1/3 x plus 5.